For my final video on quadratic sequences, I'm going to show you a slightly longer method for finding the nth term, but which will work for every sequence. Last time I showed you a comparison method where we compared with the sequence n squared, which is fine, but when we get into more complicated sequences, that can become very difficult. So I said in my first video that in a quadratic sequence, the second difference will be the same every time. So first of all, let's find out what that second difference is for these quadratic sequences. So my first difference here is 9. My second difference between 13 and 28 is 15. My next difference between 28 and 49 is 21. And then finally between 49 and 76 is 27. Okay, so I can see that my second difference is 6, 15 to 21, 6, 21 to 27, 6. So I've got a second difference of 6 every time. Now I've written my differences above my sequence, not below my sequence, for a reason, which is I'm going to write more lines of sequences underneath here. So if my second difference is 6, there's a little trick here to finding the coefficient of n squared, which is we take our 6 and divide it by 2, which gives me 3. 3 then is going to be my coefficient of n squared for this sequence, my coefficient of n squared. So I know that this sequence is related to the sequence of 3n squared. So I'm going to write out the sequence of 3n squared underneath my sequence. So when n is 1, 3, or n squared, sorry, is 1 also, so 3 times 1 is 3. When n is 2, 2 squared is 4, times 3 is 12. 3 squared is 9, times 3 is 27. 4 squared is 16, times 3 is 48. And 5 squared is 25, times 3 is 75. So I've got there the first 5 terms of the sequence 3n squared. Now I want to find the difference between the sequence 3n squared and my original sequence. So I'm going to subtract the 3n squared sequence from my sequence. So let's just write in here difference. That's what I'm going to find. Difference. Okay. So 4 subtract 3 is 1. 13 subtract 12 is 1. 28 subtract 27 is 1. And I can see that my difference is 1 every time. So that tells me that this sequence up here is the 3n sequence with 1 added to it. So that gives me a final sequence of 3n squared plus 1. Okay, so just to reiterate, we found the second difference. We halved it to get the coefficient of n squared. That gave us 3, so we had 3n squared. We wrote out the sequence of 3n squared, and we found the difference between the sequence 3n squared and the original sequence. And when we found our difference, then we knew that our sequence was the 3n squared plus 1, which was that difference. So that was our sequence up here. Okay, second sequence, let's do the same method then. So remember, the first step is to find the difference. So 5 plus 7 is 12. 12 plus 11 is 23. 23 plus 15 is 38. I can see I'm getting a second difference of 4 here. 38 plus 19 is going to give me 57. So my second difference there is 4 each time plus 4. So 4 divided by 2 is 2. That's going to be my coefficient of n squared. So we come over here and we're going to write out our sequence of 2n squared this time, because our coefficient of n squared is 2. So we write out our 2n squared sequence. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And 5 squared times 2 is 50. And then remember, we find the difference between 2n squared and our sequence. So we find the difference. I'm just going to write diff because I've not got enough space there. So that's the difference. So 5 take away 2 is 3. 12 take away 8 is 4. 23 take away 18 is 5. And here we've got a difference of 6 and a difference of 7. Well, in the first example, we had 1, 1, 1, 1, 1. That was easy. The difference was just 1. Here, our difference is forming a sequence. So we need to find the nth term of this sequence. Now, this sequence is going up in 1s each time. We're just adding on 1. We've got a common difference of 1. So this is just a linear sequence with n, and it's going to be n plus 2, right? 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 3 is 5. So this sequence here is the sequence of n plus 2. And that means that our sequence, our original sequence, is the 2n squared sequence plus the n plus 2 sequence. I'm just going to write that in green. So our sequence up at the beginning is the 2n squared sequence plus the sequence n plus 2. So our nth term is 2n squared plus n plus 2. Okay, reiterating one more time, we found the second difference and halved it to get the coefficient of n squared. We write out that sequence, so it was 2n squared. We find the difference, and then we find the nth term of the difference. And when we add the 2n squared sequence to that sequence there, which was n plus 2, we get our sequence, 2n squared plus n plus 2.